All right, in this video, we're going to be talking about graphing exponential functions. Now, we talked a little bit in lesson 7.1 about how to graph an exponential function, a basic one like y equals 2 to the x. And you'll see that that graph is here in red. And we made an xy chart and we plugged in some values like -2, -1, 0, 1, and 2 in for x. And we got our outputs. And so like I said, this is the red graph. Now, if you were to put a 3 in front, what that means is you're going to take 3 times all of these values. And so, for example, when x is equal to 0, your output is 1. But then in the blue graph, we would have to multiply 1 times 3, so the output is 3. And so when there's a number greater than 1 in front of your exponential part, it is called a stretch. It's going to rise faster, all right? And here in the next example here, we're looking at y equals 3 to the x, and that is the red graph. But this time we multiplied it by a number that is between 0 and 1, and that's called a compression. So instead of your output being at 2, you have to take, or excuse me, this is 1, your output's at 1, it would be 1 times a third is a third, it would be at a third. So it doesn't rise as fast, and so that's how it gets the name compression. And in the next example, you have a negative 1/3 in front. And so it is increasing at the same speed, but then it is reflected over the x-axis. So general form of the equations we're going to be graphing in this lesson would be y equals a times b to the x minus h plus k. So b to the x is your parent function. The a is going to represent either a stretch or a compression of that. And then the minus h, that is going to be a left or right shift, depending on the sign. So if you have a positive showing up here, what that means is that h must have been a negative, because minus a minus is what would give you a positive. So if it shows up as a positive, you're going to shift to the left. If it shows up as a negative, you would shift to the right. And the k is the up and the down shift. Depending on if it's positive, it's up. If it's negative, it's down. So to graph these, what I do is I first make an XY chart and substitute the values in for the X here and then plot those points. After that, I look at the H and then I shift to the left or right, and the K and I shift up or down. So let me give you an example here. So we're going to make a box around this and plug in values. I like to put in positives, 0, and some negatives. And it works real well to just substitute this, or to type in that equation into a calculator. The XTI 30 works great for this. 3 times 2 to the third is 24. And then you're able to just arrow up and change the exponent to a 2, and you get 12. And then change the exponent to a 1, you get 6. When you substitute in a 0, you have 3. And you substitute in a -1, you have 1.5. And substitute in a -2, you have 0.75. And lastly, we substitute in a -3, we have 0.375. So now we're going to plot those points. So we go over 3, up 24. That's way off our graph. Over 2, up 12. Over 1, up 6. At 0, we're up 3. At -1, we're up 1.5. At -2, we're up 0.75. -3, 0.3. All right, so these are the values when we substitute it into just this first part. But now we have to do the shift. So this is your left, right. And since that's a negative, you're going to go to the right one. And then you have a +4 at the end. That's a +4, so you're going to go up 4. So every point is going to go to the right one and up 4. So to the right one, up 4. 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 And then to the right one, up 4. There we go. So it's going to look just like that. This is your final graph. Now, we also want to talk about the domain of your final graph and the range. For the domain, that is referring to your inputs. You could put in positive numbers, negative numbers, and zero. So we would say your domain here is all real numbers. However, the range, if you look at the range, that's referring to your y values. You don't have any y values below 4. And so we would say that the range, your outputs, your y's are always going to be greater than 4. And this is going to have an asymptote of y equals 4. That's the line right here, the imaginary line that this graph is going to approach, but it's never going to hit. Now, in these next couple examples, we'll just talk about how we would graph it. I would make a box and put some values in here and substitute into y equals negative 2 times 5 to the x. And then you have a number up here. This is the h, which is your left, right. And since it's a positive, we would go to the left 3 with all of the points. And here, again, make the box and substitute in values, plot those points. And you don't have a number up here, so there's no shifting left or right, but you do have a plus 5 at the end, which means everything is going to go up 5 when you're done. We'll do one more. Y equals negative 2 times 1/2 to the x plus 1 and then minus 5. So we'll make a box up until the value of x, substitute in values. So we have negative 2 times 1/2 to the third. We'll put that in, and I'm going to type that in my calculator here. And that gives you a negative 0.25. And then we're going to substitute in a 2, negative 0.5, substitute in 1, negative 1, substitute in 0. Remember, anything to the 0 power is 1, so then that's times the negative 2. Substitute in a negative 1. We have negative 4, almost done here. Negative 2, we have negative 8. When we substitute in negative 3, we get negative 16. All right, let's plot those points. So if we go over 3, then we go down 0.25, go over 2, down 1/2, go over 1, down 1, over 0, down 2, go back 1, we're going to go down 4, back 2, we're going to go down 8, down back 3, and we'll go down, oh, this should have been a 16. I thought that did not seem right. Okay, and down 16. All right, so that's those are the original points, and now we have a plus 1, which means we're going to go left 1, and then we have a minus 5, which means we're going to go down 5 with every point. So to the left 1 and down 5, to the left 1, to the left 1, down 5, to the left 1, down 5, to the left 1, down 1, 2, 3, 4, 5. And so it's going to look like this. So originally, you had an asymptote at y equals 0, but all the points moved down 5, so it's at 1, 2, 3, 4, 5. So the asymptote is at y equals negative 5. So as far as our domain and our range, the domain is all reals. The range here of our final graph would be all the y values are less than a negative 5. And that's it for this lesson. Thank you for watching.